The second element that's listed down here is lithium. So if we do the electron configuration for lithium, we are writing it until we get to just the third box. This one is 2s1. So our electron configuration starts with 1s every single time. 1s will have 2 electrons in it so that we can continue on. And then 2s. And then for lithium, since it's the first box, it's just going to be 2s1. Lithium has 3 protons since it's atomic number 3. So I'm going to write 3 protons right here. And as an atom, lithium would also have 3 electrons. So as a reminder, when it's an atom, that means that it's neutral, so your protons will equal your electrons. That is what that means. And then what makes an atom stable is a full valence shell, which is looking at its outer s and p sublevels. So for lithium, the highest energy level is 2, and in the second energy level, I only have the s sublevel with 1 electron. So that means that I would have just 1 valence electron. The Bohr model for lithium would have 3 protons in the nucleus. It would also have some number of neutrons, but if we don't have a mass number, we have no way of knowing how many neutrons, so we're just going to skip that part because it also doesn't matter for this part. And then in our first energy level, the energy level closest to the nucleus, energy level 1 has 2 electrons for lithium. So electron here, an electron there. And then our second energy level 2, has just 1 electron. And in this case, that is our valence shell. So that also corresponds to that valence electron number, is that there's only 1 electron in the furthest shell from the nucleus. If you only have 1 electron in your valence shell, remember that your goal is to have a full valence shell or to become stable. What that means in energy level 2 is to have 8 total electrons. So if I have 1 and I need 8, my options are to either gain 7, or if I lose that 1 electron, then that entire second energy level goes away, and then my first energy level that's already full becomes my valence shell. So lithium is going to lose 1 electron in order to become stable. And when you lose an electron, you are losing negativity. So I like to come back to the protons and electrons here. If I have 3 protons, that's not changing. But when I lose 1 electron to become stable, instead of having 3 electrons, I will now have just 2 electrons. And so if you think about it visually, if I have 3 positive charges and only 2 negative charges, 1 positive and 1 negative will cancel out. So this one would cancel with that one, this one would cancel with that one, and we're left with just a single positive charge. So the ion for lithium looks really similar to the ion for sodium because they did the same thing. So my lithium ion would look like this, Li with a +1 charge, or we could write it the other way of Li with just a 1+, or just Li with a plus sign. And the 1 is implied there. If it's any number other than 1, you do have to write the number.